Today I'll be doing my presentation on machine learning. The phrase machine learning was coined by Arthur Samuel in 1959. He defined it as the ability to learn without being explicitly programmed. Machine learning started to really take off in the 1990s thanks to statistics and computer science being intersected to find a probabilistic approach to artificial intelligence. One of the first machine learning advances was created by IBM in 1996, which was called Deep Blue. This system played a chess match and beat the reigning world champion at the time, which was Garry Kasparov. This was such a huge achievement and nothing had ever been done before its time. Many people were skeptical at the time when Deep Blue beat Garry Kasparov and even believed it somehow cheated. What is machine learning, you may ask? It is a subfield of artificial intelligence and is essentially the science of getting computers to learn and act like humans do, as well as getting the computer to improve its learning over time in an autonomous way. NVIDIA states that machine learning at its most basic is the practice of using algorithms to parse data, learn from it, and then make a determination of prediction about something in the world. At the University of Stanford, they define it as the science of getting computers to act without being explicitly programmed. Now that you know what machine learning is at its most basic, you might ask why it even matters. Well, now that there is such an enormous amount of data, or also known as big data, it comes with problems of how to process all that data to make it actually usable. Machine learning is the key to solving this problem. Some of the areas where machine learning is already solving problems is in the field of computational finance, where there is now algorithmic trading, as well as in image processing and computer vision, which helps with face recognition and motion detection. Computational biology is another area where machine learning helps with tumor detection and DNA sequencing. It also helps in energy production for pricing as well as load forecasting. As far as automotive aerospace and manufacturing, it assists with predicting when maintenance is due. Lastly, it helps create voice recognition in the area of natural language processing. There are many different ways for a machine learning computer to actually be able to learn. There is supervised learning, which can be broken down into two parts, which are regression predictive modeling and classification predictive modeling. There is also unsupervised learning, as well as reinforcement learning. I will be covering each mean of learning in more detail. To get started, supervised learning is where a supervised learning algorithm will feed the machine data to learn. There is an existing data set containing training examples with associated correct labels, which includes the answer to the problem for each input set. It should be used to train a model to make a prediction. The first part of supervised learning is regression, which is the act of predicting a continuous numerical value or quantity such as housing prices or human lifespan. The most common way to be able to estimate the scale of regression is by using RMSE. This is an abbreviation for root, mean, squared error. An example of this is a regression predictive model made two different predictions where the first prediction was 1.5 and the expected value was 1, and then another prediction of 3.3 and the expected value was 3. The skill, or RMSE, would be equal to 0.412. Now classification, which is being able to assign a label to a particular subject, such as whether or not a picture is of a dog or a cat, is the second part of supervised learning. The picture of the dog would be placed in the dog category, and the picture of the cat would be placed in the cat category. These categories would continue to grow as more data is trained to the computer. Eventually, the computer, when confronted with an image that it has never seen before, can take what it learned by checking previous data to predict whether the unknown picture is of a dog or a cat. The more training data sets, the better, because computers will be able to better predict future unknowns. Now, unlike supervised learning, which includes the answer to the problem for each input set, unsupervised learning has no labeled outcomes or answer. Since it doesn't have an outcome, the same regression and classification methods cannot be directly applied. It instead starts with unlabeled data to be able to find similarities in data or unknown patterns. This leads to being unable to determine how accurate the patterns are. Then why use unsupervised learning, some may ask? Well, unsupervised learning is best used when there isn't any data on a desired outcome and you need to explore your data and want to train a model to find a good internal representation. An example of this would be when a company is trying to determine the target market for a new product that they have never sold before. There are different learning techniques for unsupervised learning. The first one, which is clustering, would give the company the ability to automatically split the groups of people according to how similar each one is to one another. Anomaly detection automatically discovers unusual data points in a dataset, such as being able to pinpoint a fraudulent transaction at a bank. Association mining can identify sets of items that frequently occur together in a dataset, such as identifying when products are purchased at the same time together. Companies such as Amazon use this at checkout to suggest other items you may want to purchase. Lastly, latent variable models will learn when there is some sort of missing data. An example of this would be during a clinical trial where some patients drop out and there's no way to get their data. Latent variable models would still be able to learn without this missing data. The last way of learning is with reinforcement learning. This is where an agent learns how to behave in an environment by performing actions and seeing the results. An example of this would be when a little baby cries, which would be the action, then the parent gives them the phone to watch, which is the reward. Eventually, the baby will learn to cry every time they want the phone if the parent keeps satisfying the baby with the phone when they cry. A popular use of reinforcement learning is in teaching computers to play video games. This can be seen in the development of AlphaGo, which was a machine learning software that beat the top human players in the game Go. It essentially learned by playing a multitude of times against itself until it had mastered the game. This is very significant because the legal Go positions is 10 to the 170, which is actually more than the atoms in our universe. Machine learning is only going to get more common as we go into the future. Eventually, machine learning will become a part of almost every single application, especially such as companies as Apple and Google are putting actual neural engine chips inside their smartphones to be able to have machine learning directly on a device instead of having to send that information to a cloud. This will enable developers to more easily tap into that chip to make their own apps take advantage of the power of machine learning. As computers keep getting better at speaking like a human, such as Google's virtual assistant, who can make phone calls to set up appointments all on its own while sounding like a human, we might find ourselves speaking to computers more and more. The future looks bright with machine learning leading the way, and will be very interesting to see where we are within the next 10 to 15 years. Thank you.